So this is a Hooke's Law question. So it states, so like, oh no, what's Hooke's Law? Well, the question tells you, which states the distance a spring is stretched or compressed varies directly with the force on the spring. That means it's a line, and it's a line going through the origin. And just, you don't have to write this, but I just want you to see what this means. It means right here is where the spring normally sits, or you could flip it and have it facing up, but this is where 0 is. And then if the spring goes up, it's compressed. If it hangs down further, it's stretched, okay? So if it goes up or down to, let's say, here, then we're going to stretch. And here we're going to compress. Okay, but it's all off of the 0, wherever the 0 happens to be. Okay, now it's just saying a force of 265 newtons stretches a spring 0.15 meters. What is the force required to stretch the spring 0.1 meter? How many newtons? You could just set up a ratio and solve for that, or you could do the following. You could say, well, I know that compression, okay, what is this? Stretch. Stretch, these are both stretch questions. I'm going to say stretch is equal to some constant times proportional to, varies directly with the force. Okay? And then what I'm going to do is I'm going to put in one of these points and solve for K. And then I'll just be able to use the formula. So a lot of you are formula people, so we'll just do it that way. Okay, so what's going on here? Here is the meters, which is stretching the distance, and this is the force side. Okay, so we're doing stretch is equal to K times force. Stretch is 0.15 meters. K times 265. So 0.15 over 265 equals K. 0.15 over 265 equals, wow, how obnoxious is that? We have 3 zeros and then a 5. Where was I? Okay. And then a 66038. And if that's true, then we have stretch is this value times force. Now, if this is our formula, which I'm hoping it is, will it not draw me boxes? Whatever, that's a box. Now I want to solve for this other one over here. I want to find what is the force required to stretch a string 0.1 meters. So it is 0.1 divided by that mess. Looks like 176.6665. Yeah, that's close enough. Ups, newtons. The other thing you could have done is you could have just kept this fraction in your formula. You could put S equals 0.15 over 265 force, and that would have hurt you nothing. That would be totally fine. So here's the answer to the first question. And the second question says, how far will a force of 90 newtons stretch the spring? So let's go back to this formula. I'm going to revert back to the simpler way of expressing it. how far will a force of 90 newtons stretch the spring? So just go ahead and calculate that. Again, you could just use ratios, and that's totally fine by me. And that would be 0.0509. And you're like, wow, that's really small. But we're talking meters, we're in the metric system. So it's really about 5 centimeters.